All right, it seems like I've done, I don't know, maybe like 10 of these problems in a row. But when looking at the end behavior here, we see that my degree in this polynomial is odd. My leading coefficient is 1, which is, and it's positive. So therefore, my end behavior is going to be fall left, rise right. I think I've said that like so many times. It's just been the number of problems, the ones I'm choosing to do. So anyways, the next one, I think the more interesting part of this is determining now the zero. So to do that, I need to set my output value equal to 0. And then I have g cubed plus 3g squared minus g minus 3. All right, so we've talked about, as far as finding the zeros, we could solve. But now we're looking into these polynomials with higher order, and we need to find the value of g that is going to make this equation true. Now, typically when we're doing our factoring, we either factor out a GCF, which in this case we know that none of my terms all share a common value that we can factor out. So we can't factor by GCF. And then we have a lot of other techniques, but they're always when they are trinomials or binomials. Well, here we have 4 different terms. So the only factoring technique that we've talked about so far in this course is the factor by grouping. And when by factoring by grouping, what we do is we group the first 2 terms and we group the last 2 terms. Then what we do is we factor out the GCF on each of those 2 terms. So by doing that, I get 0 equals, and I look at g cubed and 3g squared. I determine that I can factor out a g squared, which leaves me with a g plus 3. Then the negative g and negative 3, I can factor out a negative 1, and that's going to leave me with a g plus 3. Now, when factoring by grouping, you just don't factor out once. You actually have to factor twice. So therefore, I look at this again and say, what do these 2 terms have in common? Well, that's a g plus 3, of course. So now I factor out a g plus 3, and I'm left with a g squared minus 1. So there you go, ladies and gentlemen. Now we have a product equal to 0, where now I can apply the zero product property. So I say g plus 3 equals 0. And then also I have g squared minus 1 equals 0. Now, in this case, we can determine this. And what we can do is we can solve for the positive and the negative. Well, in this case, what we could do is say, all right, so I subtract 3 and say g equals negative 3 is 1, 0. Then for here, I could do either factor this, or I could use the square root method. Well, if I use the square root method, I'm just going to add 1 on both sides, and I get g squared equals 1. Take the root, and I say g equals plus or minus 1. So therefore, now I'm going to have 2 zeros from this and only 1 0 from here. Now I need to determine the multiplicity. And we're looking at the multiplicity of the zeros. We need to look at the exponent of the factor, not the exponent inside of the factor. Because a lot of students would confuse this as being a multiplicity too. But since this factor is raised to the first power, these 2 zeros, positive 1 and negative 1, have a multiplicity of 1. And so does our 0 of g minus 3. So there you go, ladies and gentlemen. That's how you determine the multiplicity of a polynomial by factoring with grouping. Thanks.